need of modulation. The most important topic, the most important tool in communication, that is modulation. What is the modulation? If you search in the Google for the definition of a modulation dictionary meaning is modulation is nothing but a change. Modulation means change. So what is the technical definition for the modulation? Modulation means it is a process of changing the one of the characteristic parameters, means maybe amplitude or frequency or phase of what? Of a carrier signal linearly in according to amplitude of the message signal. Means if you are changing the amplitude of a carrier linearly in according to amplitude of a message, called amplitude modulation. If you are changing the frequency of a carrier linearly in according to amplitude of a message, is called frequency modulation. If you are changing the phase of a carrier linearly in according to amplitude of a message, is called phase modulation. Are you understanding my point or not? Means, for example, let's take, we have a carrier signal C of t equal to AC cos 2 pi fct or sin 2 pi fct also we can take. Generally in engineering, cos we will take. Now here what I am saying, if you are changing the amplitude according to amplitude of a message, let's take message signal is some m of t, let's take. Now if we are changing the amplitude of a carrier, that is AC, linearly in according to amplitude of a message, called amplitude modulation. If you are changing the frequency of a carrier, that is frequency is varied, that is denoted with instantaneous frequency or frequency of FM. That is, if you are changing FC linearly in according to amplitude of a message, is called FM. In a similar manner, PM also. Now here, the point you need to understand, we are adding amplitude of a message to amplitude. So that is a fair conversion. But here, we are adding amplitude to frequency, not a fair. That means it's not possible. Means you are adding rupees to dollars. Both are not equal. There should be a proper conversion. Are you understand my point? Later in phase modulation also will come. So here the proper conversion will be done by the factor called KF. KF is called frequency sensitivity. What is this frequency sensitivity, sir? Frequency sensitivity will specify you how much frequency change in carrier signal per 1 volt change in message signal amplitude. Like in phase modulation, we have phase sensitivity. Sir, what is this phase sensitivity will indicate, sir? Phase sensitivity will specify you how much phase change in the carrier per 1 volt change in message signal amplitude. Are you understand my point or not? Means frequency modulation is nothing but voltage to frequency conversion. Phase modulation is nothing but voltage to phase conversion. Amplitude modulation is nothing but amplitude to amplitude. That is voltage to voltage only. Here also, of course, one parameter will come. We'll bring that parameter for our analysis purpose. We are bringing that in the mathematics because we are using the mathematics for understanding our concept. From the mathematics concept on to come. That point you need to remember. I will specify you this with further examples also. I understand my point. So here, what is another parameter is we are taking AC common. Then if you take AC common, then 1 plus 1 by AC, that is called amplitude sensitivity, that is denoted with Ka. Of course, Ka is 1 by AC we are writing as a mathematics. But Ka, this amplitude sensitivity significance is different, that you will understand in the envelope detection why we take in Ka as 1 by AC and what is the significance of Ka and what is the significance of envelope detection. Because envelope detection is the simplest technique. Because of that one, amplitude modulation is famous. Number of times the question asked in the GATE as well as engineering service examination also. What is the question? What is that question? Why amplitude modulation is famous? Or why amplitude modulation is used for broadcasting? Or why amplitude modulation is used for radio? Everything is same. Broadcasting and radio means same. Broadcasting means one to many. Radio also same, one to many. Because envelope detection. So finally, I'm concluding this. What is the modulation, sir? If you are changing the parameters of carrier according to amplitude of message, means we are keeping or we are placing message maybe in the amplitude of carrier, maybe in the phase of a carrier, maybe in the frequency of a carrier. Why, sir? Why we are unable to directly send? I will show you what is the need of that modulation. Because practically, I given the starting example also. Today I have class in Hyderabad. Tomorrow I have to take the class in Pune. I have two options. One is going by flight, one is going by walk. Then effective way, I already told you. Here also, why we are placing there? Because directly sending off our message is not possible. So that's why we are keeping or we are taking a strong signal called carrier and we are keeping our message in three different parts of it. Are you getting my point? That is the base of a communication system. Next, see the topic is very important. Need of modulation. What is the basic need of modulation? I'm not saying advantages. I'm saying need of modulation. That is the first point. So what is the first point in the need of modulation? To reduce antenna height. So first read the point. For faithful radiation of signal, the antenna height should be at least 25% of wavelength. Means, if I take the height of the antenna HT, should be at least lambda by 4. Lambda means wavelength. 25% of the wavelength. What is this meaning, sir? Let's take. For example, you can take the FM radio. In your mobile, are you able to listen the FM radio? Yes. Now, is there any cable connection from the FM station to your mobile? No. Then how we are listening? Because at the FM station there is an antenna, they are radiating, and here we are connecting the headphones, those are a receiving antenna, and we are listening. Now, what I am discussing is height of the antenna, means at the FM station, how much antenna height they have to place. Here, how much length we have to keep that headphone to receive our signal or there to radiate the signal. Are you understand my point? So, well, let me take what we are listening in FM radio. We are listening the audio signal. What is the audio signal range? 20 to 20K. But in practical, FM radio, for radiation we are taking minimum is 50, maximum is 15. Why? Because before 50, nothing will be there. And here, after 15, up to 20 is there, but you cannot take after 15. Why? Because whether for a musically untrained people, whether if you include that 5K or delete, we never feel difference in the song. So that's why important bit also in engineering service examination, number of times asked. The maximum frequency considered in the audio signal of FM 15 kilo. For example, if you go for AM radio, maximum frequency considered is only 5K. So in AM 5 kilo, FM 15 kilo, maximum frequency considered in the message. So now you can compare AM and FM. If you are comparing AM and FM, where is the clarity more in the song? Definitely in the FM. You can feel that difference. You can listen the song in AM radio and listen the song in FM radio. Definitely you will feel the difference. In AM, maximum frequency considered 5 kilo, FM 15 kilo. So I taken 50 to 15 kilo. Directly if we are radiating, let's see. Let's calculate the height of the antenna. Height of the antenna HT equal to lambda. Lambda means C by F. So C by F. F means I am taking as FM. M means message. In the previous I taken C. C means carrier, like that. And I taken I. I means instantaneous, like that. What is the C value? 3 into 10 power 8 meters per second by 4 into, what is the FM value? Maximum, let's take 15K. 15 into 10 power 3. Let's calculate. You will get 5 into 10 power 3. So I can say 5 kilometer. Means directly if we want to radiate audio signal at the stations, we need to construct an antenna height of 5 kilometers vertically on the ground. Is it possible to construct the antenna height of 5 kilometers vertically on the ground? And the maintenance is possible? Obviously not. Are you getting my point or not? So, construction of antenna height 5 kilometers vertical on the ground, it's not possible. So radiation is not possible. So that's why we are using the concept of modulation. I given definition of modulation in the previously one definition. Another also I can say modulation is nothing but what is another definition I given? Modulation is a process of increasing the signal frequency. Now, what is the carriers we are using in FM? In FM, 88 to 108 megahertz. This is a FM frequency all over the world. Are you getting my point? Now, I am using the modulator. What is happening inside the modulator? What is the modulator? What are the methods we are having? All those further we will discuss. Are you understand my point? This 15K I am giving and modulator I am using carrier frequency 100. So I am getting the output is 100 megahertz. What is happening that what are the methods we'll discuss later. Now calculate the height of the antenna. If you calculate the height of the antenna, C value 3 into 10 power 8. 4 into now FM is increased to 100 mega. You will get a 0.75 meters. Even you can also see practical FM antennas are a few hundreds of centimeters. Here if you see in Hyderabad, we have FM stations in Begumpet. See the height of the antenna there. And we are also having AM station also. It is nearer to LB Nagar in Hyderabad if I take. Are you getting my point? Like here, what is the first advantage or first need we got? Here antenna construction is not possible. Here 0.75 meters means we can easily construct the antenna and we can radiate. Why I taken 100 also? 88 to 108 is a practical FM. So middle value I taken and I shown. So because of doing modulation, antenna height is reduced and practically we can construct, we can radiate our signal. Now follow. What is the FM range I told? 88 to 108. Like we are also having AM radio, amplitude modulation radio. This, are you getting my point? This carrier frequency is 550 kilo to 1650 kilo. And in FM, maximum frequency considered 15K. In AM, I told 5K. And what is the total range we are taking in FM? 50 to 15 kilo. And where is the clarity more? Obviously in FM. So that's why in the starting topic also, when I comes to the TV, whenever there is a transmission of audio, FM. Of course, video VSBC, that's another discussion. Are you getting my point or not? Second point in the need of modulation is for multiplexing. What is multiplexing, sir? Let's take a simple example in our home. Let's take a TV. from the antenna to your TV, how many cables are there? Only one cable, sir. Okay. And how many channels are possible? Hundreds of channels are possible. Means those hundreds of channels are coming with the same cable na? Means here transmission of more number of signals through a single channel itself is called multiplexing. If you want to go for multiplexing, modulation is must and should. Why, sir? Why modulation is must and should? I can take a simple point. For example, now you are listening the communication class. Same time you are listening the signals class. Same time you are listening the mathematics class. Because all three subjects are taught by faculty. All are same Y signal or maybe video. Means Y signal means 300 to 3.4. Video means 0 to 4.5. All are at the same frequency range. Then all will be interfere. You will get the mixing of these three subjects. So you never get any single mark in the GATE exam. Do you understand my point? Like, I generally told this example in the classrooms. Whenever if you maintain a single nodes like all in one, all will be mixed up. You will get a new subject. From that new subject, no questions in GATE. So maintain proper notes for each and every subject. That is important. That notes is your life. That notes is your GATE exam. That notes is your job. That notes is your money. Everything. So maintain the notes as properly. So anyhow, whenever all signals are in the same frequency band, if you want to transmit, because if you take a TV example, whatever may be the channel, if you see, maybe audio or video. Audio frequency range is 20 to 20K, video is 0 to 4.5. All channels are same. You can see any channel apart from these two, any other thing? Audio and video? No. All are in the same frequency spectrums. So, if we want to separate them properly, are you getting my point? We need different carrier frequencies, means we need the modulation. I will tell you here overallly, and about this one still you will get further clarity in the FDM topic, that is frequency division multiplexing topic. You will get the full clarity over that. Are you understand my point? Follow. Now here, what I am saying, for example, we have a channel of 100 kilo and I want to transmit 10 messages which is existing from each message from 0 to 10. So what we are doing in that case, we are using first carrier frequency in such a manner that first message we are fitting from 0 to 10. Second carrier frequency we are taking in such a manner that second message we are replacing to, because if you do the modulation, then frequency replacement, that is frequency translation will happen. Like you seen in the modulation theorem, m of t, of course I told there x of t multiplied with cos omega naught t is shift 1 by 2 into x of omega minus omega naught omega plus omega naught. Frequency translation will happen. That is frequency shifting property or modulation theorem I told. So second carrier we are taking in such a manner that second message we are shifting to 10 to 20. Like third message 20 to 30, 30 to 40. Like we are dividing that cable, that is channel bandwidth, and we are splitting between the channels, and all are making in such a manner that no interference. There is a concept of guard band also there. Guard band means we need to leave some gap between each and every message, because of filters are not ideal filters we cannot design, because in the receiver side we are having band pass filters to separate each and every message, like 0 to 10 first band pass filter, 10 to 20 second band pass filter, like that. But filters are not ideal. Some falling characteristics, that is some transmission bands will come. So to avoid that we are using some guard bands. If you see practically in FM radio, guard band is 20K. 20 kilohertz is the guard band that is inbuilt in the each and every station itself. because in each station is of 200 kHz bandwidth FM stations. In 200, 20 is for only left space because for the God band. So anyhow, this multiplexing will be possible if you do the modulation. Without modulation, multiplexing is not possible. Are you understand my point? For example, if you want to multiplex the voice signals, what is the modulation scheme we are using is SSBSC. Why SSBSC is SSBSC is having better advantages in terms of bandwidth, in terms of power. That we will get back to the point I am saying. Are you got my point or not? Third basic need is to increase SNR value. Where I told about SNR point, SNR means first thing, signal to noise ratio. This you have to understand. I told this point in the basic block diagram of a communication system. If SNR value is good at the input of a receiver, then final clarity of a received means reconstructed signal will be excellent. Because ultimately, what is our purpose? To get back our message in a excellent manner. Means you are preparing for the GATE examination. What is your ultimate goal? Your ultimate goal should be, final result should be excellent. Whatever maybe you done in that 1 year or 2 years of span, no one will take care of about that. Whether you succeed or not. Like here also, customer don't bother about what you are doing in the communication. You are putting transistor or leaving or op amp or whatever you are doing, whatever circuit, it doesn't bother. Finally, for example, he is talking over the phone. Finally, what he feels that whether the clarity of the voice is coming or not. If you see in any movie, whether the movie clarity is good or bad, like that. Here, that is depending upon the SNR value at the input of a receiver. And practically, our messages are a very weak signals. So, practically those are not suitable to transmit through the channel even for a 1 meter also. Are you understand my point or not? So, what we are doing, sir? We are doing modulation. Means we are adding a very strong signal called carrier. Means I told in the modulation definition, we are placing our message in the amplitude of carrier, frequency of carrier, phase of carrier. Because carrier is a strong signal, it can suitable for transmit through thousands of kilometers to the channel or atmosphere. So we are adding to the strong signal means signal strength we are increasing. If you keep signal strength more means this SNR value far greater than 1. SNR value far greater than 1 means I can say signal can be reconstructed. If SNR value is less than 1, I can say that signal can't be reconstructed. I can take simple example. Suppose you are seeing my video lectures. The voice of this video lecture is more when compared to all other disturbances in your room, like fan, AC, environment, your children's and parents. And if you compare means all these voice, if my voice strength is more, then my voice will be reachable to your ears. You will listen what I am saying. Whether understanding or not is a different case, but I definitely listen. Suppose if my voice strength is low when compared to all other external disturbances, then you cannot listen what I am saying. Are you got my point or not? So here, crucial important point of SNR, to make that one more, we are doing the modulation. See the next point in the need of modulation. Fourth point is interference. What is this interference, sir? For example, if two FM stations, means two base stations are using same carrier frequency, for example, first station is using 2 MHz, second station also using 2 MHz, then there is a interference will happen. So what we are doing by using modulation, we are making different carrier frequencies. Because of making different carrier frequency, that interference can be avoided. Using different carrier frequencies means we are using we are taking the help of a modulation. Next point, power radiated. Power radiated from the antenna is directly proportional to L by lambda whole square. Power radiated from the antenna means at the transmitting side antenna will be there, na? That antenna power radiated will be directly proportional to L by lambda whole square, where L is the length of a linear antenna and lambda is the wavelength. If the signal frequency is increases, then wavelength will be decreases. If F is increases, then lambda will decrease. If lambda is decreasing, then obviously power radiation from the antenna will increase. Next point, poor reception. Poor reception means receiving the signal at our mobile, means mobile is nothing but our receiver or radio. Are you getting my point? Because energy reception is equal to F into H, students. Energy reception, this is at the receiver side I am saying. Energy reception is equal to F into H. If the signal frequency is more, then obviously energy reception will be more. Why? Because signal is traveling from the longer distances, it is becoming as a weak signal. Still, if F is low, then energy reception is still low. Are you getting my point? So by doing modulation means frequency will increases, then obviously energy reception will be good. Next point is, because of doing modulation, we are replacing wired communication to wireless. Simple example is, you can take a radio. If you don't have this modulation, then obviously we have to keep some cables from FM station to your mobile or radio. Because of using that modulation, we are replacing the cables or wire to a wireless medium. Clear? Next point is, wideband signal is converted into narrowband signal. What is this wideband signal? Narrowband signals are here. Wideband and narrowband is here. We are taking the ratio of highest frequency to lowest frequency in the signal. If highest to lowest frequency ratio is far greater than 1, that is called wideband signal. Approximately 1 called narrowband signal. Clear? Follow. For example, let's take our audio signal. Audio signal, what is the frequency range? Frequency range is 20 to 20K. Are you getting my point or not? 20 to 20K means, let's take the ratio of highest frequency to lowest frequency. 20K by 20, then 1K means 1000. Far greater than 1 means it is a wideband signal. Now, listen first, then you will get the clarity. Now what I am doing is, I am doing modulation. Modulation means what I told, frequency translation. I am using the carrier frequency of, for example, 100 mega. Because in FM station, carrier frequency is 100 mega. Means what will happen? This is shifted to 100 mega. Are you getting my point? So this is shifted to 100 mega means, I can say 100 mega plus 22, 100 mega plus 20K. In mathematics, if you take this lower sideband, this is called upper sideband frequencies. Lower sideband also will come. That's not a matter. Now, let's take highest frequency to lowest frequency ratio, or maybe you can also take in LSP. That's not a matter, I'm saying. If you take, that will be approximately 1 will come. So this is called narrow band signal. Are you getting my point or not? The ratio of highest to lowest far greater than 1, wide band, approximately 1 is called narrow band. So how this wide band signal is converted as narrow band, sir? by doing the modulation. Modulation means frequency translation. So what is the advantage, sir? Practically, if you say the construction of the antenna will be easy for a narrow band signal when compared to the wide band. Or I can also say one more point also. First point is height of the antenna, where we had to place the height of the antenna. Now I can say size of a antenna. Size of a antenna is small for narrow band signal when compared to wide band signal. First point we are saying height. Now I am saying size of a antenna. Are you getting my point or not? So because of this narrow band signal, the construction of antenna will be easy and easy for radiation. These are the 8 points we are discussing about the need of a modulation. Clear?